In this video, we're going to take a look at some basic reasons for tides and one way to visualize them. So in this model that I have here, you'll see that I've got the Earth right here, and we're looking at it down from the North Pole. So we're looking at it down from above. And you'll see that the Earth kind of has an exaggerated ring of water around it. Alright, that's so we can help to show where it's high tide and help to show where it's low tide. Obviously, this is highly exaggerated. Next thing we'll look at here is the biggest factor for the tides, and that's the moon. And what the moon does is the moon has gravity. And even though the moon is still a lot smaller than the Earth, its gravity is significant when it comes to our tides, and it pulls the Earth and objects on the Earth towards the moon. Now, most objects on the Earth aren't going to be affected by this, but something fluid, like water, can be affected by this. So what you end up with is you end up with a situation where you get water on the side that's facing towards the moon bulging up. Right, this water is getting pulled up by the moon's gravity, so you get this bulge over here on this side. The name for that, we call that a tidal bulge. Now, the next thing we're going to look at is a little bit more tricky, and people often have questions about that, and that is the fact that the moon also pulls the Earth towards it somewhat. All right. Now, if we're to visualize the amount of gravity or the effect of gravity on the moon, we could draw a little graph here that would show this. And this is gravity, and this is distance. And as you're close to the moon, the gravity is high, and as you get further away, the gravity drops off. So this side of the Earth experiences a pull of gravity of a certain strength, but this side of the Earth, it also experiences gravity, but it's not quite as strong. Right? The pull isn't as great. So whereas the planet gets pulled over towards the moon some, this water on the far side of the planet does not get pulled as much. So some of it stays behind. All right, some of it can get pulled over a little bit, but overall you end up with a second tidal bulge on the opposite side of the planet because of that shift right here. Watch, the Earth shifts over towards the moon, but this water on this side doesn't shift. So you end up with a second tidal bulge. Now, at any given time on the planet, you've got two tidal bulges, one facing towards the moon, one facing away. All right, the areas that are underneath these tidal bulges are experiencing high tide. So at any given point time, you've got two areas of the planet experiencing high tide. All right, one on the side facing the moon, one on the side opposite from the moon. Now, what's going on up here? What's going on the sides that are not experiencing high tide? Well, that's where the water is getting drawn from. We talked already about this idea that water is getting pulled up by gravity over here. Well, that pulls water away from these areas that are not directly in line with the moon. So those areas right there, right, so you've got one over here on this side of the planet and one over here on this side of the planet. So remember, we're looking down at the top. So this isn't the North Pole over here. This is just a side of the planet along the equator. These areas are experiencing low tide. And again, just like you had two areas with high tide at any given point, you also have two areas with low tide at any given point. Alright, now let's look and find out where New York City is on here. So I'll go ahead and put a dot in the approximate location of New York City. There we go. And of course, what does the Earth do during the day? The Earth is going to rotate. Right? So the Earth rotates, and you'll notice that as it rotates, that spot, New York City on the map, is moving from an area of high tide to an area of low tide and back to an area of high tide. Right? So within one day, you get New York moving through these tidal phases. Alright, so New Next, here you've got New York underneath this tidal bulge, so it's high tide. Continues to rotate. It goes to the next tidal bulge, or this goes to low tide right here. Then it goes back to a high tide, and finally again to a low tide. So here we start kind of halfway in between this high tide. So at any given day, we're going to have 2 high tides and 2 low tides. So here we're starting kind of halfway through a high tide. Then we go to a low tide. Then we go through an entire high tide cycle. Then we get the other half of the second high tide cycle. Right, so we've got 2 high tides and 2 low tides. Now, you might ask, well, how long does this take? You might think, well, 24 hours, because that's how long it takes the Earth to rotate 360 degrees. But there's one other thing going on, and that is that the moon is also moving during this time. So you'll see the moon right here shifts a little bit during the day. Right? Not too much. It's not a very dramatic shift, but it's still significant. All right. Now you'll notice that as the moon shifts, so does the location of the tidal bulge. Remember, it's the moon's gravity here that we're concerned about with this tidal bulge. So here goes the moon here, then it shifts, now the tidal bulge shifts. So whereas before, this spot right here was the highest spot, right underneath this high point of the tidal bulge, but when it shifts, this spot is no longer underneath the high spot. Now this is the highest spot. So in order to make one complete cycle, the planet actually has to spin, right? It starts here, and it makes one complete 360-degree rotation. But remember, that's not quite enough, because now the tidal bulge has shifted, so it's got to spin a little bit more to get to this next point, right, and get back to that high tide. So as a result, it takes slightly more than 24 hours for one complete tide cycle. This extra little bit here takes 50 minutes. All right, that's how long that represents. So you've got 24 hours to go around from here to here, right? So from here to here is 24 hours plus 50 minutes. So one tidal cycle, right, one cycle is 24 hours plus 50 minutes. Now, you can do a little bit of math and you can figure out, well, if one cycle takes 24 hours and 50 minutes, well then half a cycle is 12 hours and 25 minutes. Right? So that would be from high tide to high tide, or you could think about it from low tide to low tide. So you're going from this high tide over here to this high tide over here. That's half the cycle. This low tide right here to this low tide right here, that would take 12 hours, 25 minutes. That is half the cycle. Alright, now you also notice that as the moon continues to revolve around Earth, that throughout a month, remember it takes about a month for the moon to make one revolution around Earth, that location of the tidal bulge continues to shift the entire time. Alright, now the moon is the biggest factor by far for our tides, but there is one other important thing. In order to see that, we need to zoom out a little bit, and we bring in this guy over here, right? Big yellow thing over to the right. That's the sun. Okay, sun is very big. Now, it's far away, but because of its immense size, it does have a significant effect on the tides. The effect that it has on the tides here is that it can actually, its gravity will actually cause the water to move towards it as well. So where you have the moon's gravity pulling water towards the moon, you also have the sun's gravity pulling water towards the sun. Now the sun is very far away, so the effect is not as pronounced. But when you get in certain situations, the effect of the moon's gravity plus the sun's gravity plus the sun's gravity when they're working together, right, you can have extra big tidal bulges, right, because they're both pulling water in there, so you have bigger tidal bulges, and this means that you have bigger high tides, and because you're pulling more water over here, right, you're getting more water into the tidal bulge. The tidal bulge is going somewhere to form that bigger tidal bulge. Well, that water has to come somewhere, so it comes from these areas that are having low tides, but because you're pulling so much more water, the low tides are lower. All right, so let's take a look here. If we've got, and when this happens, we call this a spring tide. You can think of it as the tides springing back and forth. Don't think of it as the season spring, because these spring tides can happen any season, summer, winter, fall, spring. But this tides are springing way back and forth between an extreme high and an extreme low. So at a spring tide high, all right, if this is the beach, all right, if this is a beach at a spring tide high, and we'll do the beach here in a second at a spring tide low, at a high, you're going to have the water way up near the top. At a low, you're going to have the water not nearly as high. The water is going to be out much further, right? Remember, because that water, the two objects here, their gravity is working together to cause more water to get pulled over here into this tidal bulge. So the areas where you'd have a low tide, here and here, they're getting more water taken away from them. So you end up with this bigger difference between a high tide and a low tide. Alright, so here's the swing during a spring tide. You have a bigger swing. Now, the spring tide it's most obvious to understand when it's occurring when everything's in a line here. But remember that in this arrangement too, you also get tidal bulges on opposite sides. So this is another arrangement for spring tides. Right, so you get spring tides here during the full moon, and you get spring tides, I'm sorry, that's not the full moon, during the new moon, and you get spring tides here during the full moon. So there are two different moon phases that cause spring tides. So it happens 2 times a lunar cycle. Alright, so those are your spring tides. Next, we're going to look at what happens here. Right, in this arrangement, right here, you've got something else going on. Well, you've got the moon doing its thing, trying to pull water up towards it, causing the high tides, the tidal bulges here, and the high tides underneath those tidal bulges. But hey, wait a second, you've also got the sun, and the sun is pulling this way. And the moon is trying to get this water up here, and the sun is trying to say, well, not so fast, right? I want to keep some of that water over here. You can't have it, right? And in this arrangement, the sun's gravity works against the moon's gravity. And we call this arrangement a neap tide. All right, I like to say neep, neep, nice short little word, neep, so you have tiny little differences between high and low. So if here's your beach during a high tide, here's your beach during a low tide, the water level at the high tide, it's going to go up some, right, but not nearly as much as during a spring tide. And here's your water level during a low tide. It's going to go down, but not as much as during a spring tide, right? You've got these two forces working against each other, right? So here's your swing between high and low between the neap tide, right? Remember, the sun's gravity is working against the moon's gravity. You don't have as much swing. So the neap tide can occur in this position, right? You've got the moon in the first quarter. And the other arrangement is when the moon is down here. You can also have a neap tide when the moon is down here in third quarter. So in both cases, you get spring tides twice a month, and you get neap tides twice. Well, it might be more accurate to say 2 times a lunar cycle. Alright, so you can use your calculations for the time between moon phases to calculate the time between neap tides. Right, so if you've got a neap tide here and your whole lunar cycle takes about 29 days, well then the amount of time between neap tides is going to be half of that, right, about 14 and a half days. Alright, now, we looked at gravity from the moon and sun. These are two major factors that influence tides, but there are lots of other things, right? One thing is that if we look at the moon's orbit, and I'll exaggerate here a lot, because it's pretty circular, but the moon's orbit is not perfectly circular, so sometimes the moon is closer to the Earth than other times, right? And that can cause bigger tidal swings. There are other factors as well. Local factors, such as the shape of the coastline, are big. Right? Shape of the coastline, are you in an inlet? Are you on a flat beach that's facing the ocean? Is it shallow offshore from where you are? There's a lot of different things that can affect tides in specific areas. And these, and anywhere on the planet, there are a lot of different factors, and tidal patterns can vary widely depending on where you are on the planet. The tilt of the moon's orbit is also a factor. It's not as much of a factor, but it is a factor. And then you don't really have to know this, but some people want to know a little bit. The Earth's spin causes the water to have some inertia, or causes the water to have some momentum with that spin of the Earth, and then the water's inertia also comes into effect and can have some interesting effects on the tides and the timing of everything. All right, but we don't need to know that. I just want you to kind of be aware that that's out there. All right, and if you go into a little bit more advanced study of tides, then which we're not going to do in this class, but then you would need to know those things. All right, thank you very much. Please let me know if you have any questions.